today we're going to be talking about properties of my favorite kind of triangle, an isosceles triangle. And if you remember, an isosceles triangle is a triangle where two sides are equal and one side is different. So I'm going to draw my isosceles triangle right here. So in this isosceles triangle, this side is the same as this side. Now, the interesting thing about triangles is the sides, this side for example, its length is determined from the angle over here. So however big this angle is will affect however big that line is. And the same thing is true for all the other angles. However large this angle is, this side will be larger. And our one angle that's different, we'll draw two lines there and two lines here, controls how large this side is. So in our isosceles triangle, if we know that this side is equal to this side, we also know that these two angles are also equal. They are equal to each other. This angle is the angle that is different. So we're going to use that knowledge to try and solve a problem. It's still our isosceles triangle, and this side is still different. In our problem, this angle is equal to 31 degrees. I'm going to ask you, what are the angle measures of the other two unknown angles? So we have to kind of put together all of our information that we know about a triangle. First, we know a triangle is equal to 180 degrees. I'm going to move that down just a little bit. We also know that I've already used up 31 degrees. And I have to figure out how much is left over. Well, my first step should be to subtract 180 from 31. So that's what I'll do. I have to borrow. 10 minus 1 is 9. 7 minus 3 is 4. And bring down my 1. 149 degrees. So this portion over here is equal to 149 degrees. But I'm not really sure what that shows me. I know it's 149, but does that mean this angle is 149? Or this angle is 149? Let's think back to my properties of an isosceles triangle. I know that these two angles are equal, and I have two of them. So that means I have to take this 149 and cut it in half. I have to divide it by 2. So 2 goes into 1 0 times, 2 goes into 14 7 times. 7 times 2 is 14. I have to subtract 0. Bring down my 9. 2 goes into 9 4 times. 4 times 2 is 8. I subtract. I have a 1. I do not want to report it as a remainder. I want to report it as a decimal. That means I need to put my decimal right here, bring it straight up, and continue. Bring down my 0. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and I get 0. So 74 and 5/10 is what each of these two angles is equal to. Oops, excuse me, I wrote my decimal in the wrong spot. Gotta fix that. That's how we figure out a missing angle measure for an isosceles triangle.